5-0. Honestly, I would expect it to take you about an hour. I hesitate to say this because every time I do it's a lie, but I don't think this is a very difficult test. I wrote the test, but, right? The test has 10 matching to start. And you want a hint on what's in the matching?
Yeah, sure.
Yeah, know your Japanese. Following the 10 matching is 29 multiple choice questions. And I'll give you a look at 2 or 3 of those this morning. And then following that are 11 quantitative questions that are again multiple guess. Most of the emphasis in this particular area has been on total quality management and inventory. So that's where you're going to see most of the questions come from. In the quantitative, there will be assembly line balancing and inventory. Okay. So let's jump right into it here. So we started this block by talking about a game, right? We started, it was production engineering, the game we played. Someone tell me what the big takeaways from that particular game are. Yep.
Learning curve?
Yeah, definitely there's a learning curve on things. So what do we know about learning curves?
They increase at a steady rate.
One more time, Matt.
I was just going to say they increase at a steady rate.
Okay, so they're not linear, right? But you kind of go up and then you hit diminishing returns on it. So you're going to learn a lot at the beginning and then it kind of tapers off. And what's the nice thing about a learning curve? It's pretty much the same every time. Not the same in terms of value, but the same in terms of they generally follow this pattern. What else? What else that game teaches? Yeah.
Sloganeering's not helpful.
Yeah, it's not helpful. Slogans don't work, right? And what do we mean exactly by that? Well, you're out there cheering people on, patting them on the back, and you're not giving them useful training and useful training aids, it's useless. Okay, what else?
Cue cards?
Oh yeah, training aids, right? Cue cards, training aids, very effective. What about re-engineering?
Nope.
Say it again, real loud.
That's not a good idea.
Not a good idea, why? What is re-engineering?
Starting over from scratch.
Throwing out everything we know and starting from scratch. What's the problem with it?
Doesn't work.
Yeah, kind of, it doesn't work, it fails, and we see that in software, new software projects fail at a very high rate. Yeah,
Another problem is you can't use prior knowledge or things that you've been working on mostly like your whole life.
right. So what's the right way to implement change?
To take what you already know and adjust it to fit the new need.
Right on. And what concept does this fit really nice with later on?
Quality management.
Total quality management, it's all about improving a little bit at a time and continually improving, right? Continual process improvement. Okay. Anything else from this game? Yeah.
There's going to be Project Assassins and Champions.
Yeah, product assassins and product champions. What usually dictates where someone is? Why are people assassins? Yeah, they just don't like change. That's really common. And why would we have champions? Yeah. They're looking at it, seeing the improvement. Along with slogans, talk to me about numerical goals. Like baptisms this month, discussions this month, yeah.
Well, they're misleading, they kind of get to the wrong point.
Yeah, so what should we be motivating? Quality and improvement, yeah.
I would say like, it's very difficult to not focus on numbers, and on certain things I think you have to. But do you think focusing on like projects or events can do that? Like we have to be done by this deadline type of thing, or?
Yeah, projects are just a little different, aren't they? Because, well, what are we trying to do? We're actually trying to forecast when we're going to finish each segment. What this is saying is those, I forget which, well, we have it going on right now. So our advisory board is pushing us to try to have a 50-50 ratio men to women in supply chain management. The highest percentage group in the Marriott School is accounting, and they're 20% women. So we're kind of like, okay, if we go shut down the School of Family Life, right, and the nursing program and some of the other traditional LDS women kind of attract programs, maybe. The problem with numerical goals, again, is they just a lot of times motivate the wrong behavior. And in that particular case, in project management, you have to keep on time, on schedule, or you're never going to finish. So that's probably the right behavior in that case. Okay, anything else? Okay. The product process matrix. This is chapter 3 on process design. What are the 5 types of manufacturing? Anyone? Yes.
So like the continuous flow,
Yeah.
job stations.
So let's start with a project. And on the graph, remember the graph is type of product you're producing on bottom, whether it's one product or several different highly differentiated products. So one commodity product or highly differentiated products. And then on the other one is economies of scale. So are we looking for high efficiency or high customization?
Can you just draw that real quick? For some reason I can't picture it.
Make sure I'm drawing it correctly.
How many penny now?
6x6.
Wait, it covers what?
This is the supply chain strategy.
And
There's international business.
that's go.
No problem. I hardly offer like a Russian, but hardly.
I figured out. it's even less common. I'm taking business. It's actually a really cool class. We do all these competitions and pretty sick.
I'm excited to do what?
Like case competitions. Yeah, like within our class.
Oh, yeah, we had, like, I guess, yeah, we had like
It's sick. We like compete against each other, and it's all it's just fun.
the guy that we're doing the project fail is the guy that I'm doing. It's on
Oh, nice. Cool. You got a clock. Clock she's got it, yeah. NBA student?
Yeah. Oh, he's an NBA?
Ever remember this? Okay, so if I'm creating a one-of-a-kind, I'm not that concerned about efficiency, I'm more concerned about creating a unique product. I'm going to use what? Project, right? If I want some efficiency, but I also want some ability to change, a little bit of flexibility, I'm going to use probably assembly line. That's why we have assembly lines. Very efficient, but they allow us some flexibility. Why is there overlap here? Yeah, there's hybrids. So there's not necessarily pure of all these. Yeah.
Is batch the same as Webb Center?
Yeah. Just wanted to use what's in the textbook because they use a little different language, I think, than I gave you original.
What I have is job shop is work center and batch would be manufacturing center.
Yeah. So what do you have, one more time?
Job shop is work center. The middle one is manufacturing center.
So on the exam, I went back through the textbook to make sure I was using language consistent with the textbook. So you'll see job shop badge. So how are these different? What happens in a project? How's that set up? Well, let's look at building a house. That's a project, right? So when you build a house, what do you do?
Design the floor plan.
Design the plan beginning to end. This is when my electricians are going to come in, this is when plumbers are going to come in. And they come to the project, and they might all be working on the project at the same time. How's that different than a work center or a job shop? By the way, I kind of like this job shop, because what's it sound like you have?
Job.
Yeah, each shop within your production facility has its own little job. So in that case, I'm trying to think of a good job shop place. Like it might be your job in the job shop. You're the painter. So if you go to Counts Customs or some of those that do these custom-made cars, you have one person that does all the hand painting, all the graphics on a car. You have another person whose job it is to get all the dents out, get the frame nice and straight. So it goes from one specialist doing a job to another specialist doing a job.
So don't they do that on like a lot of different products too? Or is it-
This is where it gets a little fuzzy. The answer is yes. But as we move down this efficiency line, what we see is trying to do kind of the same type of thing here, but similar processing is done here. So this is not, you're not necessarily an expert on hand painting in this. You might be an expert on putting graphics on things. And it might be you paint, you put stickers on, but it's all in your little cell. Right, so everything that flows through that needs that sort of stuff done, you do all that. So much more cross-functional, much less of a specialist. Yeah.
So for summer I interned at Bell Helicopter. We made, working on gearboxes, and so we had like these like work centers that would just do certain grindings and certain gears. Would that be a batch or a job shop?
It would actually probably be right here. A little bit of both. So you guys specialized in just doing that gear, but if you needed to do more grinding on something that wasn't a gear, you could probably do that as well. Yeah.
So you saying the reason why you said the difference between a job shop and a batch is essentially that a job shop, like one car is completely unique versus a batch might be more of a pet.
You're working on more than one product at a time for sure in a batch.
And you're more product, yeah.
So as the name infers,
Yeah.
you're working on a batch of items here.
Okay.
So you might have 15 cars coming through and you're doing something on every car. Where in a job shop, you have a product flowing through, you do your thing on that product, then you push it to the next job shop.
Okay.
Assembly line, all about efficiency, and again, trying to get the flexibility. You're trying to get some of the flexibility that happens in batch, but you're trying to do it as close to continuous flow as possible. Okay, I would know these. They make really nice multiple choice kind of questions, right? You're trying to do this, which type of production would you use? All right, then we need to talk about balancing. Assembly line balancing, and I have an example here. Let's kind of walk through this example real quickly. Why do I balance an assembly line? What's it do for me? Must begin towards the end of the semester at 8 o'clock in the morning. Okay, so the idea behind assembly line balancing, and real quickly, we go all the way back to our reading and the goal. Where's my bottleneck? Yeah, this one is taking 5 minutes or 5 seconds or 5 days, we'll pretend it's minutes. So I have a person working here at a machine, a person working here at a machine, person here, person here, person here. And they have to do task A, B, C, D, and E in order to make the machine. What's wrong with the way I have this set up right now? Go ahead.
You're gonna get a lot of stuff right before 5. It's gonna pile up.
Yeah, so stuff's gonna pile up here. So we're gonna have tons of inventory here.
And then 4 and 1 are gonna be waiting all the time.
Yeah, and these are gonna be waiting for it to come out. As soon as it comes out, it's gonna pop off the end. So this person's going to be waiting 4 seconds. This person's gonna be waiting 1 second. And these guys can produce, they're gonna produce a lot, but then you're gonna have inventory buildup, so they're gonna need to take a break too. Because he has 3 extra seconds or minutes, he has 2. So what do we do in assembly line balancing? Yeah.
You basically assign one person to say, hey, you're over A and B, and one person saying they're over D and E.
Yeah, so we want to make this more efficient, right? So rather than have 5 people on this assembly line, we say, look, you are now workstation 1. This is workstation 2. And this becomes workstation 3. And lo and behold, look what we've done. Now workstation 1 takes 5. We have 5 here, 5 here. This is a totally balanced assembly line, meaning every workstation is taking exactly 5 seconds. What's nice about this?
Wasting labor.
Yeah, we're not wasting people's time, right? They're always busy doing something. We're always going to be keeping these workstations fully employed. And the efficiency goes way up. Also, we're able to predict exactly how many we're going to get off the assembly line. Because we know right now in this particular thing, every 5 seconds, a new thing is going to drop off the assembly line. Questions? Questions about the concept before we get into the how-to? Okay,